Today, we're going to be talking about different types of line pairs and angle pairs. Copy down these definitions. Parallel is a term you've learned in previous years of math, but you'll notice in geometry you use parallel a lot more, and also the word parallel is defined in a much more technical way than in previous years of math. Write this down. Parallel lines are coplanar lines that do not intersect. Coplanar means they are on the same plane. There are two lines on the same flat surface. These two lines are parallel because they're on the flat surface of the screen in front of you, and no matter how far you extend them, they're never going to intersect or run into each other. After you write down that definition, copy this part down. These two lines, two vertical lines next to each other between two line names, that's actually mathematician shorthand for the term parallel or parallel to. So out loud you would read this as line AB is parallel to line CD. And that will be a very useful shorthand for you personally as you go through the rest of chapter 3. Skew lines are non-coplanar lines that do not intersect. So notice how the only difference in the definition between skew and parallel is the word coplanar in parallel and non-coplanar in skew. Here's some examples of what skew lines might look like. So being non-coplanar and never intersecting might look like this. Your two lines might be on completely different planes, one above the other, and therefore never intersect because of that. Or you could have a skew line compared to other lines that is skew and never intersects them because it only briefly passes through the plane the other lines are on, like line M here. All right, we're going to practice identifying whether lines are parallel, skew, or neither option. So take a look at the diagram on the right. Let's find segment DA and segment EF from question number 1, and then highlight them, DA and EF, here and here. Now that we've highlighted them, look at them. It looks like they're never going to intersect, but are they never intersecting because they're parallel or because they are skew? Very good, they're skew. They're on completely different planes, different sides of your shape. Look at question 2. If you go highlight CB and FG, decide whether that's parallel, skew, or neither. If you said parallel, well down, they're lined up the same direction, they're on the same plane. Go ahead and try number 3. Number 3, you should get parallel. They're lined up the same direction, and you could create a diagonal plane that would contain them both. So they are technically coplanar because you could draw a plane that contains AB and EF. Try number 4. If you look at EH and DC, they are never going to intersect, and they're not on the same plane. There's no way to draw a plane that contains them both. So that would be skew. Number 5, if you highlight EF and FC, you'll notice how they do intersect, so that'd be neither. If they intersect, it can't be parallel or skew because a major part of both of those definitions is that your two lines never intersect, never run into each other. So you would write neither because they're intersecting, and it looks like they might be actually perpendicular lines, which is an option we haven't talked about yet. It'd be hard to prove because we don't know for sure that's a right angle, but it looks like it might be. Now, the great majority of the rest of today's notes are definitions for you to copy down, and they're definitions you'll be using for the entire rest of chapter 3, so take detailed notes on them. First, parallel planes. Not only can you have parallel lines, but you can have parallel planes, two planes that never intersect, no matter how far you extend the edges, like these. Next definition, transversal. This is a word you'll be using quite a bit for the rest of the semester. A transversal is a line that intersects or crosses two or more lines. So this line here, because it's going across these two lines, would be considered a transversal. Next, jot down these short definitions of common words as we use them in everyday life. And then after that, we're going to apply them to angle pairs. In everyday English, the word interior means inside. For example, interior design. Exterior means outside, like exterior paint job on a car. Corresponding is a fancy word for things that match in some way. And often the word alternate means opposite in some contexts. Those definitions will be especially important when we start looking at angle pairs. Now, if you're filling out your notes on printed paper for the next bit, you'll want at least 2 different color pens or pencils because you'll be wanting to color code these angle pairs as we label them. So on the first diagram below, in one color pen, label these 2 angles with the same name. These 2 angles would be called alternate exterior angles. If you look at the definitions for alternate and exterior that you wrote down earlier, alternate is opposite, exterior means outside. The reason why these 2 angles are called a pair of alternate exterior angles is this. They are an alternate or opposite sides of the transversal here. One's on the left, one's on the right side of the transversal. Alternate sides. But they are exterior, the 2 lines that the transversal crosses. They are outside those 2 lines. Hence, alternate exterior angles. In a different color pen or pencil, or if you're on your iPad, just change colors, label these 2 angles on the same diagram. These 2 angles would be called alternate interior angles. They are on alternate sides of your transversal. One's on the left side of the transversal line, one's on the right side. But they are interior, the 2 lines of the transversal crosses. They are inside those 2 lines. Now on the last diagram on your page, choose another color and label these 2 angles on that last diagram. These 2 angles would be considered a pair of same-side interior angles. They're called same-side because they're both on the left side of the transversal. They're interior, the 2 lines of transversal crosses. And in a 4th color pen or pencil, label these 2 angles. These would be called a pair of corresponding angles. You have corresponding angles anytime you have angles that are in matching positions. Like these 2, they're both in the upper right quadrant of the T or X shape made where 2 lines cross. They're in matching locations. They are corresponding. They're facing the same direction. Now these 4 types of angle pairs are going to play a key part in the rest of Chapter 3, so you really want to memorize them today. We're going to practice identifying them. Take a look at this picture. Decide which of those 4 angle pairs you have here. What sort of angle pair do you have here? What would this pair of angles be called? What about these? And these? What's this pair called? And what are these? All right, we're going to make it a little bit harder. What would you call this pair of angles? What would these be called? What sort of angle pair do you have here? What are these?